All right, so today we're working on simplifying square roots. So remembering what a square root is, first let's start with just talking about what a perfect square is. We did this a little bit when we did our factoring. So let's just remind ourselves, shall we? Okay, so 1 squared, okay, x squared is x squared is x squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81, 100, 121, 144. You get bigger than this and I can't do it in my head. All right. And honestly, I don't recommend that you try to memorize every single perfect square. Having these first ones down will be beneficial to you, but honestly, anything bigger than 12, you're not going to really have ready in your brain at a moment's notice anyway. That's why we have calculators. All right. But being able to recognize some initial basic ones will be of great help to you. All right. So looking down, what exactly is a square root? So if b squared equals a, then b is a square root of a. All right. So what this is saying is the radical symbol represents the non-negative square root. All right. B squared equals a, then b is a square root of a, meaning, look at this. If 2 squared equals 4, then 2 is the square root of 4. All right, sometimes it makes a lot more sense when you see it in with numbers than it does if you see it in letters and a little more abstract. All right, so a radical is an expression of the form looks like this or looks like this, where x is a number or expression. Radicand, that's the number beneath the radical sign. So in our examples here, that's our x. All right, the index is the root that is being taken. That's a small number on the outside of the radical. So just drawing here. All right, so the little symbol is called a radical. This is the radicand. And this number out here, this is called the index. When we do not see a number here, as you typically don't, I mean, look at this one. All right, you typically don't. That's saying a square root, the index is assumed to be 2. This is the one and only time in math where we have a ninja 2. Okay, so you've heard of ninja 1s, we now have a ninja 2. So let's go to our steps here of simplifying radicals. My pen is not letting me pick any colors. That is really weird. Maybe, can I go this way? Hey, okay, now we have blue. Sorry guys, I hate trying to do these videos and write with black pen. Everything just blends in. All right, so simplifying radicals. Step 1, factor out any perfect squares in the radicand. Step 2, take the square root of the perfect square and place it in front of the radical. And 3, the remaining factors remain as the radicand, the number inside the radical. All right, so let's look at the first one. This is saying the square root of 36. Well, 36 is a perfect square. So we know that the square root of 36 is 6. All right, now we've got 20. 20 isn't a perfect square. All right, but if we break this down, right, we know that 20 breaks down into 4 and 5, right? Well, 4 here is a perfect square. We know that it's 2 times 2. So we're going to take the 2 out because that's the square root of 4. And this 5, that doesn't break down any further, is going to stay in. All right, the square root of 17. How do you make 17 when you multiply? Yeah, the astute among you has recognized 17 is a prime number. All right, so 17 we can't do anything with. All right, that's it. That is the answer. The square root of 17 is the square root of 17. That's as simple as she gets. All right, if you are seeing one like this, where it's asked you to find the square root of a prime number on a quiz or a test or a homework, please give me some indication that you realized that you could not simplify it any further. Draw a box around it like I've done here, write down already in simplest terms, does not factor, prime, something. Give me some indication that you recognized what it was. Don't just leave it blank. Because if you leave it blank, that means to me that you had no idea what you were doing. So give me some indication that you knew what you were doing, you just couldn't do anything with it, all right? Okay, square root of 45. Well, 45 is 9 times 5, right? And 9 does have a square root, it's 3 times 3. So we're going to take a 3 out. And this 5 doesn't break down any further, so it stays under the radical. All right, next, negative square root of 32. Okay, pay attention to this one because it's got a negative sign out here. All right, that says that whatever we take out from under this radical is going to be multiplied times a -1, right? Remember, we could say that we have a ninja 1 here. All right, so let's break down 32. Let's find the factorization of this. So 32 is 8 times 4. 4 breaks down to 2 times 2. 8 breaks down to 2 times 4. And 4 again is 2 times 2. All right, so what we're doing here, and I want to show you a different way of doing this because this has got 2 numbers that break down into it that have square roots. So what we're looking for, because this is a square root, remember our little index is this ninja 2, we're looking for groups of 2 numbers that match. All right, and then we're going to take those groups out. So I have a group of 2's that are coming out here. So I got my negative ninja 1 that's already out here, a group of 2 that comes out, another group of 2 that comes out, and then this 2 all by himself that doesn't have any friends that stays in. All right, so my final answer is -1 times 2, which makes it -2. -2 times 2 makes it -4. So my answer is -4 radical 2. All right, and we do follow the same process for the rest of these. Let's practice with this 75 here. And then we'll do this one. All right, just so you have a couple more that you see. So 75, let's break this guy down. All right, well, 75 we know is 3 times 25, right? It's the easiest way to make that. And 25 is 5 times 5. All right, it's a square root, so we're looking at a group of 2 numbers that match. Hey, look here, I got a pair of 5s. So A5 comes out. A3 doesn't have a buddy, he stays in. And they already had this negative sign out here. So that's remember we got a negative ninja 1 there. So it needs to be multiplied by this 5. So it gives us -5 radical 3. The last one. I have 5 times the square root of 27. So let's break this guy down. 27 we know is 3 and 9. 9 is 3 and 3. It's a square root. So I'm looking for a pair of numbers that match to come out. I have a group of 3's. So 3 comes out. My 5 was already out here, so remember it gets multiplied by whatever comes out. Then I have a lonely 3 that nobody likes here who doesn't get to come out, so he stays in. So then I need to do my multiplication, clean this up. So 5 times 3 is 15, radical 3, and that is my final answer. All right. As always, if you all have any questions, be sure to send me an email, and good luck with your homework.